Hello again. This is the next session, which introduce you to computer graphics and visualization. Actually, we will be talking about computer graphics right now. So, this is, as you see, on a computer, graphics are displayed by a processor, or like you can say, this is the display process of computer graphics. So, what we do, like when we model or when we draw on computer using software application like AutoCAD, SolidWorks, CATIA, similar software applications, it will uh, communicate with graphics system. That means maybe graphic kernel or this software, actually the base of software. Here we use two methods usually. uh, we call raster graphics and vector graphics. We will talk about that next step. And whatever the graphics generated by the graphic system, it gives an output on display. And also maybe and you might get an uh, I'm not sure what does it maybe some of the, like say, a touch panel, maybe touch screen, those kind of feedback devices can be taken as input and output. So this is the like interface with the human, and these are done within the computer system. So these are the application areas of computer graphics. Already you know these: computer designing, presentation, computer artwork, and also education training, visualization, image processing, entertainment like movies, gaming, and in medical field also graphics are used, computer graphics are used. So computer system for graphics means like it divides into two parts: computer hardware and computer software. So the software runs on computer hardware. uh, these are the computer hardware which you use monitor or display, and buffers like to keep the data memory or process with digital processing unit, and keep store memory, and display controller. So these are the computer graphic components of computer graphic displays. And before, like this is not much necessary, but it's good to know, like before we use cathode ray tubes or CRT. Right now we have LED flat screens. These are a kind of tube, like older TVs. These were there, a tube, and you get picture projected on this by electron beams. So these are you will be supplying power for these pins, and according to whatever your information, electron gun will fire, and uh, there will be a control grid. Beams will be this electrons will be controlled by this control grid voltage and the focusing system, and there will be a deflector in x direction and y direction. So Mainly these are controlled, electrons are controlled by gun and the grid voltage. So electrons passes through these and spread and project on this phosphorus wall. So there are two methods in on CRT also projecting: random scan, raster scan, and also like later on color TV and DVST or direct view storage, flat panel displays, plasma panel displays, LCD, and there are new more display types are there. So this is just for you to understand. So in CRTs, I told you there are two methods or techniques that produce pictures. One is raster scan. In this, uh, electron beams like projected on the screen, and it it travels horizontally always. Each second, maybe a millisecond, I'm not sure about the time, so it grows quickly lines. So by uh, by uh, by projecting, look at here. So this is actually a color one. Okay, on this screen, phosphorus screen, one dot will be displayed, and but still the electron beam will be traveling on screen, like scanning through the screen. So while scanning, picture generates by shooting a dot by dots every time. So this happens very fast, and until the eliminate dot, you can see the picture. So this is how it generates. Always beam travels horizontally and goes down. So picture, you will generate picture. Now once it goes come, it will start from top again, and next next picture, next what you call next slide will be displayed in raster scan. In random scan, the electron beam directly projects where you want to make your graphic. So here a line, it will directly project from here, and it grows from here to there. So like that, in random scan, you pictures will be created and you can see it. So this is how the color CRTs work. There will be electron guns with color blue, green, and red. So according to the picture, these are three base colors. From these, on the screen, colors will be produced. Like combination of these colors, you can generate any other color by combination of these base colors. So graphic software works within a graphic kernel. So graphic kernel is it's the software application runs on a kernel which communicate to the CPU, memory, and devices. So in graphic kernel, usually you get vector graphics, where let me go to the next slide. So I'll first tell you what is vector graphics and raster graphics, so you can distinguish difference. So this is how an image represents this kind of picture element, small element we call pixels. So in every pixel it will be black or white. So by creating black on white picture, a white background pixels, you get an image. So in this method you create raster graphics pixel by pixel. Pixel is the smallest screen element. It depends on this pixel size depends on the various screens. And here's the comparison. So I told you raster graphics is are created by, see, the letter E, created by coloring these pixels. So when you zoom it and see, when you enlarge it, the picture is not all that clear. You get blurry, like all these edges will be shown. So these are good to work with small scale pictures, but if you enlarge it, the picture get blur. So to avoid that, or like not to avoid, actually to find in design process, we don't use raster graphics. Maybe you will use raster graphics in like gaming movies, likewise. But in our work we will use only vector graphics. So in vector graphics is much different. In vector graphics we will use mathematical equations. First, what you do, like according to the point, or the think of you the screen xy coordinates, you will generate anchor points, and like this, which are shown in red color. You can, if you want later to create or the model letter E, you have to make anchor points, and depending on line types you can draw the whole, you can connect the points. So in this method you have to create all the points according to your picture and connect points together with lines. So this is vector graphics, and it uses mathematical equations like for circle equation, line equation, likewise. So generally we use raster graphics for video representation, music videos, movies, and other kind of graphic work, and vector graphics for design, CAD work actually. So these are the general difference with the vector graphics and raster graphics. The pixel in raster graphics, pixels are used, but in vector, mathematical curves, lines are used. So difference is, when you enlarge this, you get blur, but when you, even though you enlarge this, you get perfect shape, because these points are anchored and the curves are passing through the lines are passing through the our anchor points. So you get a clear picture even though you enlarge it, and this is can be easily modified also, because you change the anchor point position, then the picture will be changed. So after graphics are good for photographs, and for this, as I said, CAD design work, vector graphics are ideal. Raster graphics are nowadays this problem is not there, because there are uh, uh, vector graphics you can find over the internet. Models are there, you can take and modify. So in raster graphics we use actually every day, like you take a picture from your mobile phone or from a camera, then that is raster graphics. So the image size is uh, large, the file size is large. In vector graphics it's only mathematical equations and data, so files size is small. We, uh, file size is small as because what we save these positions only and the line types and the whatever the graphical software, once you give the input data point positions and line types, it will generate the picture itself. And you can see all the very detailed image from here. So this is the difference between uh, line and vector graphics. And here in this system we use usually vector graphics. So main primitives, so polyline, the line type, polymaker, we will learn about this later on. Fill area, text cell, these are all main primitives of graphical kernel systems. You don't have to remember all these, just for take an idea. So remember raster, what is raster graphics, what is vector graphics. So these are graphic primitives: lines, circles, arc, point, square, polygon. So from these we can generate any 2D picture design by combining or subtracting these shapes, this basic element. So computer aided drafting or CAD is usually what you do. It's a drawing technique where engineering drawings are produced with assistance of computer. So what you do manually, you can produce in engineering drawing. The same way computer can be used more faster computer design drawings or drafting designs. um, so these are the advantages using CAD systems. Drawing quality of the drawing independent. uh, Actually, what I want to say is drawing quality is high because computer does the work for you, and CAD libraries can create. So you can draw a part and you can store and you can record it and you can use. Also, you can use layers like for line, say um, you can you can switch between layers, and layer means on screen there will be a set of pictures kept in on different virtual screens and combine all together to see the picture. So on a layer maybe a very thick line, and to show the object outline on another layer we can add to show the inside of the object, the part. And you can toggle between screens, like you can stop it the dotted line and you can see the square line screen. Likewise you can toggle, and also you can create multi-color drawings for visualization, for you to understand easily the picture or design. You can use colors, and you can create uh, color drawings with multicolor drawings on CAD system, and very easily you can modify the picture or the graphics you created by editing the equations. So these are the advantages of computer graphics. systems. So mostly the base software of CAD software is written on Fortran or C language. So from Fortran, you can generate codes, the equations, or in same way from C language you can create equations. And for equations, what we do is by software, the graphical software will be used these uh, sequence, this base software, and produce your graphics. So there are few standards for CAD. uh, this means file format. There are few file formats, standard file formats. IGES is the common file format you can exchange with various graphical software such as AutoCAD, SolidWorks, CATIA. For all these, you can open IGES files. So this is about CAD. What I forgot to tell you is, like, in graphical hardware there will be a GPU, graphical processing unit, or graphic display processor. So you need, for you to use computer graphics on your computer, the GPU should be a good one, especially for simulation or rendering visualization. Rendering means like you'll be visualizing with the natural way, in the natural way, so you can process more realistic with rendering techniques. So for this you need a good GPU and good memory, or higher memory capacity for your work. If not, if there's no GPU, the graphic part system will be using your memory of the processor, memory and processor, which is there to process software information, and that will be busy, so your computer might work very slowly. So for that, uh, you just read the book and remember what I said, and understand the difference between raster graphics and vector graphics. So I'll stop from here and I'll see you on next session. Thank you.